Okay, chapter 3.7, formulas and functions. Mostly going to be solving formulas. Simple formula like the area formula. Area equals length times width. Okay, so this is the formula for area. If we know the length and the width, say the length equals 20 centimeters and the width equals 5 centimeters. We can solve it. We just plug the length and the width in for the length and the width in the formula. You guys know how to do this. Area equals 20 times 5 equals 100. So area equals 100 centimeters to the second power because it's a two-directional. We're multiplying length by width. So we get square centimeters, which is different than distance. The length is a distance and the width is a distance, but the area has length and width. And so we end up with a grid with 100 centimeters in it, 20 by 5. 20 rows with 5 in each, or 20 column or 5 rows with 20 in each. Depends on how we do that. Okay, so here's kind of where it gets interesting though in algebra. We might decide that we want to solve for length, or we might want to solve for width. And so when they're asking you to use a formula or a function, they might say as a function of W, area as a function of width. So we're going to just change area. Area equals length times width, so that instead of area being by itself, width is by itself. And really all you have to do is divide both sides by L. Okay, so this goes to, see, these cancel out, and it's over here. So the width equals the area divided by the length. Okay, now we have it in terms of W. This is area, but it's in terms of W. W is by itself. So that's what we're looking for. So if I know the area and I know the length, I can find the width. So for instance, if you get a story problem where the area equals 100 centimeters squared, and the length equals 25 centimeters, then we'd have to find the width. So it's just width equals 100 divided by 25 equals 4 centimeters. So the width would be then equal to 4 centimeters. So we'd have a length of 25, a width of 4 centimeters, and the total area would be 100 centimeters. So we can work backwards. A lot of times we have a formula and we can rewrite it so that it's in the terms that we want to. That we want to have it in. Alright, so that's kind of what they're looking at. They give you a temperature conversion. They give you interest rate. I equals PRT. You probably should take note of this. This is one you should memorize. P is principal. PAL, just like the principal in school. Okay, so we're back in this. Interest equals principal times rate times time. P is the principal. R is the rate, which is the percentage. So for instance, if it's 6%, that's written down as 0.06. Okay. Time is usually in years. T is time. And we'll do it in most of these math books. It'll be in years. And I is the interest. Now this is simple interest, so we're only compounding. It's just the simple problem. Interest equals principal times rate times time. Now the book says that, say you have invested $1,500. You've invested $1,500. And that you earned $54. Okay, in 1 year. So this has all the components. This is the principal. $1,500 is what you invested. The 54 is the interest that you earned, and the 1 year is the time. And the only thing missing is the rate. So this book is wanting you to rewrite things so that it's in function of the letter R, or function of the rate. So we don't have to do it that way, but it works. We'll just go I equals PRT. Okay, we're going to divide everything by principal and time on both sides. And that's going to leave us with that cancels out and that cancels out. That's going to leave us with the rate equals interest divided by the principal. Here we write that, the principal times the time. Okay, so this is the new equation. And we just plug in the things that we know. Okay, so the rate is a percentage. We don't know what that is yet. Equals the interest, which is $54, over the rate, over the principal, which is $1,500, times the time, which is just 1. So it ends up being 54 divided by 1,500. And if we go to our calculator real quick, clear. Why is that still showing me something? 54 divided by 1,500 is equal to, 54 divided by 15 is equal to 0.36. So this is 3.6% if we move the decimal over twice, 0.036. This is equal to 0.036, which is 3.6%. So the rate is what they wanted you to find out, and that's how that works. Okay, pretty quick, pretty easy. Basically, they're just going to ask you to solve for something. For instance, they might have the area of a triangle, which is 1/2 times base times height, and they might just say, well, solve it for the base, or solve it for the height. Let's solve it for the height. We'll try to get the h by itself. So to get rid of the 1/2, we're just going to multiply both sides by 2. So that's 2 times the area equals base times height. And then to get the h by itself, we're going to just divide both sides by b. And that'll cancel off. And this means 2 times the area divided by b is equal to the height, or height is equal to 2a over b. Okay? So you're just rearranging the equation, rearrange the problem. Okay. They have a couple of harder ones. They'll say rewrite the equation so that y is a function of x. So you'll have a bunch of stuff and you're just going to get y by itself. Okay? So 1/5 over times 25 minus 5y equals 4x minus 9y plus 13. Alright, so now 1/5 works with 25 and it works with 5. So we're going to go ahead and just multiply these in using the distributive property. 1/5 times 25 is 25/5, which is 5. And 1/5 times 5 is 1. So it's just 5 minus y equals 4x minus 9y plus 13. We're going to get all of our y's on one side and get this number on the other side. But let's add 9y first to both sides. Negative 9y, positive 9y cancels out. So we have y plus 8y, or 5 plus 8y equals 4x plus 13. Let's subtract 5 from both sides. That cancels out. So we have 8y. Looks like a 5 kind of, huh? Yeah, because it was 1. I just changed it to an 8. 8y equals 4x plus 8. And then we're going to divide both sides by 8. And you can do it like this, where you would divide each term by 8, or you can just divide the whole thing by 8. In my head, it's a little bit easier to do it this way. Again, it depends on what the problem looks like. But then we have y by itself, and this ends up being 1/2 x. 4/8 is the same as 1/2, plus 1. 8/8 is the same as 1. And this is what the final solution looks like. This is rewriting it so that y is a function of x. We have y here as the function. Okay? Nice. I think that'll do it. You guys can work on it from there. Have a great time. Talk to you later.